This video is going to focus on Learning Objective 6-5, which talks about the photoelectric effect. And the photoelectric effect is actually a really simple experiment, but it explains some really deep physics, or at least gave us hints at some really deep physics. One of the really key things the photoelectric effect allowed us to do is design solar panels, and that's what we're going to be talking about in this video. So let's start with this. When you touch a charged object like this balloon right here, which has a bunch of electrons on it, to a metal, which originally is neutral, the metal can become charged. And the photoelectric effect comes in where you take a UV lamp and you shine it on that charged metal. And when you do that, these electrons that are added here, they get launched off of the metal, and eventually that's going to cause the can to become negatively charged. Or sorry, to become neutral. Okay, so just this idea that a light can remove electrons from metal. It actually seems really simple. How do we use that, though? How did scientists take that idea and then use it to design these panels that can steal energy or absorb energy from sunlight? Well, let's start with this. Solar panels are made from silicon semiconductors. A semiconductor is a special material that acts as a conductor under certain conditions. So it can conduct electricity, but it doesn't always. And there's two different types of semiconductors we're going to be talking about when we talk about solar panels. The first is an N-type semiconductor. N-type semiconductors give up electrons. The N in N-type stands for negative. So N-type semiconductors end up giving up these negative charges, whereas the other type, the P-type semiconductor, accepts electrons, and it accepts electrons because it tends to be positive. P stands for positive. So because semiconductors are a kind of metal, they exhibit the photoelectric effect. And so when light hits an N-type semiconductor, it's going to release the electrons from the N-type semiconductor. And then those electrons that have now been released, if you can use like a wire to give them a path to a P-type semiconductor, then they can be accepted by the P-type semiconductor. And what you essentially create is a battery that works whenever there is light shining on those two semiconductors. And that's what a solar panel is. I'm going to show you a picture down here, and we're going to get into a little bit of the details. So here's our N-type semiconductor. Notice the negative charges right there because it is the N-type, whereas here's the P-type semiconductor. When sunlight comes in and hits the N-type semiconductor, it's going to push electrons out of the semiconductor and into a wire. Now, once we have all these electrons being pushed out in this wire, we can just connect it to the other side, creating a circuit, and all these electrons are going to be absorbed by the P-type semiconductor. And then when sunlight hits the material again, it's going to cause those electrons to jump back over here and kind of replenish the N-type semiconductor, which kind of closes the loop. And so whenever there is sunlight, you're going to get a movement of charge through this circuit because there's a difference in electric potential between the N-type semiconductor and the P-type semiconductor that can be measured as a voltage. As long as you have voltage, you can have electricity.